Okay, so now I want to do some further discussions on that problem 5.1. I divided the video because when you use the camera it's too big, and now I actually realize that I need to shave, so I'm going to try to shave for my next video just for you guys. Okay, this problem 5.1, okay? So we have here, we know that step 2 was the bottleneck. That's what I realized in the next video. So we can ask a few questions, right? Okay, we know by the 5 steps of the process of the theory of constraint, we need to look and elevate the bottleneck, right? So how can I produce more? What would you do to produce more than 3 per hour, right? So you have to look at process 2. That's the most important process step, right? So first, I need to make sure that it doesn't get starved, right? I don't have any shortage of material, because this will basically be the speed of my whole system, right? Like the highway example where you have like many lanes, right? And then you go do 2 lanes, and then you do, remember, 2 lanes again, right? Remember that example that we saw in class? Uh, so yeah, I can put the cars here if you want. What happened is you have a lot of inventory here, right? You have a lot of queue of a lot of cars before you have the bottleneck, right? The same thing will happen here. This can produce 4 per hour, but this can only consume 3 per hour. So here is where your inventory is going to increase. After this process step, everything is going to flow very quickly because you're doing 3 per hour, and this guy here, process 4, step 4, can do 5 per hour. So it's going to have some extra time that has nothing to do. The same thing for this one. You have a lot of lanes, but you have very few traffic because the traffic is all stopped here, right? So you can do 3 per hour. This can do 5 per hour, but he's only going to do 3 because only 3 are going to come from this process. The same thing here. And this guy, this is the job that you want to do. So if you can choose the job that you want to do process step number 5. Because only 3 per hour are going to come, and he can do 6 per hour. So in fact, he's only using 50% of his time. Okay, so it's also important. So that's an important concept, right? Based on what we just saw in very kind of simple example of traffic, right? Congestions and all that. And then another thing that's important is that you need to make sure that this process doesn't stop, right? It's working all the time. And, this process can stop for 10 minutes, 15 minutes, this one, and this one. And if they keep the 3 per hour, they're good, right? So they can lose some efficiency in the other ones, but this one cannot, right? And these other steps are called non-bottleneck steps. All these steps are non-bottleneck steps, and this, of course, is the bottleneck step, right? So make sure that I don't lose time here, and I'm okay of losing some time in the other ones, okay? Another important concept here is, okay, what can I do to increase productivity, right? To produce more, right? So it doesn't make any sense to try to invest in a new machine for step 1 or step 5 and 3 and 4. They don't matter now. The only one that matters is step 2. So if I want to increase productivity here, or production volume, produce more per hour, I need to put more resources here in step number 2. Maybe put another person, make the process quicker and easier, and maybe divide it into other steps. So there's some few things that you can do to try to make this process work more, increase the capacity here, and then it will increase the capacity of all of them. So let's say that I can do 5 per hour. Now it's not the bottleneck anymore, right? And this becomes 12. And then these processes become the bottleneck, right? Then I have to look at these now. So that's kind of the cyclical. Remember that it has 5 steps, and they're cyclical in the bottleneck. So that's the cyclical kind of element, right? So now I have another bottleneck, and then it can go on and on, okay?